Last episode we multiplied chain rule links by hand. Find for 2 layers, hopeless for a million weights. So how does a computer do it automatically? Picture an assembly line. Each station takes parts, does one small operation and passes the result on. Write that line down and you have a graph. Stations are nodes, the belts between them are edges. Run it left to right and every node records its output. That's the forward pass. Now here's the trick. Each node also knows its own little derivative, how its output reacts to its inputs. Call those the local gradients. Reverse mode autodiff starts at the output with a seed of 1 and walks backward, multiplying each node's local gradient into the signal coming from above. By the chain rule, that product accumulated back to any input is exactly its derivative. This is PyTorch AutoGrad. Every operation you write quietly builds this graph. Calling backward runs the reverse sweep. Reverse mode gets all parameter gradients in one pass, which is why it beats forward mode when parameters vastly outnumber outputs. Here's the whole thing in one file. We build a tiny graph for Z on bows on the plus sin x, do it once with PyTorch AutoGrad and once by hand, and confirm they agree. First we set x and y as tensors, which requires grad on, so PyTorch starts recording the graph. We compute z there forward. PyTorch silently stores every node and edge as we go. We call backward on z, which runs reverse mode autodiff and fills in the gradients on x and y. Then we write the gradients by hand. Dez dx is y polus cos x, dez dys is x, and evaluate them. We print both side by side and plot them as paired bars, AutoGrad and hand-derived site at identical heights. Build a graph, sweep it backward once, get every gradient free. Next episode, we turn this machinery on a real little neural net and derive backprop end to end.